For question 7.3, you have a circuit of inductors and resistors. There's a 0.5 Henry inductor, 2 ohm resistor, and a 4 ohm resistor, and a dependent current source 3I. I is the current flowing through the inductor. Ix is the current flowing through the 2 ohm resistor. You have to find I of t and I of x. And the initial voltage of the initial current flowing through the inductor is 10 ampere. To find I of t, you use the first order equation for current. I of t would be the initial current e to the t by tau, e to the minus t by tau. You know the initial current is 10. You have to find tau. Tau would be the inductance by the equivalent resistance. The equivalent resistance, we need to calculate equivalent resistance in across from the terminals of the inductor. So to find that out, you can use Thevenin. You can replace the. You can find out the Thevenin resistance across the terminals of the inductor. To find the Thevenin resistance, you replace the inductor with the 1 volt power supply. So you get this circuit where I1 is the current flowing through the first loop, I2 is the current flowing through the second loop, and I0 is the current flowing from the 1 volt resistor, 1 volt power supply. I0 would be the opposite of, would be negative of I1, since they both are flowing in opposite directions. And the Thevenin resistance would be the voltage by the current 1 by I0. So to find, you have to find I0 here. To find I0, you apply KVL across the two loops, I1 and I2. For the first loop, you get 2 times of the current flowing through the 2 ohm resistor. So 2 I1 minus I2, because I1 and I2 are flowing in opposite directions across the 2 ohm resistor, plus the 1 volt power supply. For the second loop, you have the same thing, 2 times of I2 minus I1 minus 3I1, the dependent current source, and the 4 ohm resistor, and I2 is flowing through the 4 ohm resistor. You simplify the second equation and you get I2 is 5 by 6 I1, and you substitute that in the first equation. I2 minus I1 is minus 1 by 2. You get I1 as minus 3 ampere. So since I0 is minus I1, you get I0 as 3 ampere. You get the Thevenin resistance as 1 by 3 ohm. Since you know the Thevenin resistance, you can calculate tau here. So the inductance is 1 by 2 and the equivalent resistance is 1 by 3. You get 3 by 2 seconds as the time constant, and you get the current flowing through the inductor as 10 e to the minus 2 by 3t. Next, you'll have to calculate what Ix is, the current flowing through the 2 ohm resistor. To find the current flowing through the 2 ohm resistor, you would need the voltage across the 2 ohm resistor. Since the inductor and the resistor are in parallel, the voltage across the 2 ohm resistor is the same as the voltage across the inductor. And you know the current flowing through the inductor is this. And you can calculate the voltage by using the equation for inductor, L di by dt, and you differentiate the current equation. When you simplify this, you get the voltage across the inductor as minus 10 by 3 e to the minus 2 by 3t. That would be the same as the voltage across the resistor, since they both are in parallel. So you get Ix as the voltage across the inductor divided by the resistance is 2. So when you simplify it, you get Ix as minus 5 by 2 e to the 2 by 3t.